Hello, this is going to be a video tutorial on using the open source software called OpenRefine to clean up and regularize data sets. And the particular problem that I've been facing in my own research, I'm an anthropologist and I work with very big, very messy data sets. So cleaning up data is something you spend a lot of time doing. And when the data sets are huge, you need to use all the help you can get from software to make your life easier. So in my particular use case, what I was confronted with was a case where there was a lot of data that had already been entered, and that data was messy. There were cases where there was spelling mistakes, so you have here an entry for rest, also an entry for rest with a period after it. This is normal when you have a lot of people collecting data and entering it. Errors creep in. You also have issues of language arising, and in any case, regularizing these data or placing all of these data into cleaner categories. It's a normal thing to have to be doing. So I found that OpenRefine provides some really great tools for doing this kind of work. But I couldn't find a tutorial that handled my particular use case, so I thought it might be good for other users out there like me to be able to see a video on how to achieve a situation where you have these messy data becoming regularized. So in my case, I wanted to take all of this messy data and place all of these entries into only one of five categories. This is like post hoc data validation. You're basically reverse engineering what really great data entry would have been like after the fact. So here's our behavioral categories. Here's the data as entered. Another constraint I was facing, which is a really important one, is that you want all of these steps of data processing to be reproducible. And you never want to be throwing away or overwriting the original data. While this data might have problems with it, you don't ever want to get rid of those original data entries. After all, you might want to revisit some of the choices you make. You might even want to be recoding the same raw data several different ways. So this is all the more reason to never be overwriting your original data. What I wanted to end up with was a mapping between the data as entered originally here on the left, and on the right a corresponding coding scheme where only one of these five categories is applied to each of the raw entries. So that's what I was aiming for. So before I start with OpenRefine, I'll demonstrate what is really the most important and the first step that you have to take in order to get to where we want to be going. And that is simply to take the original data, to copy it and paste it verbatim in a neighboring column. I'm going to give this the title behavioral category. Save that file. So that's an important step. Now we're going to fire up OpenRefine. I've already installed it on my machine. OpenRefine is software was originally written to work on a server and to be driven through a web browser. So when you start up OpenRefine, it's going to both open up its own tools, but also open up your browser, and which gives you a client to your local machine as a server. Okay, so first thing you do here with OpenRefine is you load up some raw data. You can either be fetching data from a URL online, or in our case, we're going to be taking it from our local machine. So here is the data. And hit next. So the first thing, it just shows you, exactly what you've just uploaded. Looks good. So the next step is to be creating your project. So go ahead and create your project. This gives you access to the tools in a workspace. So the first thing that we're going to be doing here, just to be able to see all the data, we're going to expand it to 50 rows, is we're going to be using what are called facets. Facets are, my apologies to anyone out there who developed this software, but my understanding of a facet is that it's essentially a list of unique entries. And then you can do lots of interesting things with those facets. So with categorical data here, what we want to be doing is computing a facet, and this is called a text facet in our case. So let it do the faceting. I imagine, of course, if this was, numerical data, my description of what a facet is would be totally different. But in the case of categorical data, text data, like we're working with here, it gives you a list of all the unique entries, which is nice. Then now here's where the cool stuff starts, which is that you can use clustering techniques to be able to combine some of these entries. So we're going to hit this cluster button here, and it'll go through and apply whatever algorithm is selected. The defaults here are key collision with some measure of similarity called fingerprint. You can change this. So let's, just for the sake of it here, use nearest neighbor. Nearest neighbor with different measures of distance. I'm going to go back to key collision because it gives you my sense is that key collision usually finds nice categories for somewhat messier data. But just for demo here, you can also change the keying function here as you wish. So in any case, you can play with this, but you end up with a schema that's showing you what the software thinks might be useful categories or clusters. So in our case, what you have to do then is go through each one of these clusters and explicitly tell it, yes, do merge these. And that is also the step in which we are going to basically enforce our coding scheme here. So here it is for reference, the behavioral categories we're shooting for. So yeah, we will take this suggestion, gladly change all these entries to just eating. Again here, all of these entries here that's identified as similar are likewise going to be happily recoded as just cooking. Rest, or rest with a period, we can tell the software to please recode this as resting. Eating food, we're going to simplify that to just eating, following our schema. Nap, we're going to be recoding this. Chatting, this is going to be our talking category. Read is going to be our reading category. Talking to a friend is going to be just talking. And yes, this is data entry that we're doing here. You can't avoid some amount of data entry, that's for sure. But the difference between doing this by hand in Excel or some other spreadsheet and doing it in Google Refine or OpenRefine is really significant in terms of its time saving and reproducibility. So napping here, we'll be recoding that as resting. Nap is going to also fall in the category of resting. Cooking rice is going to be simplified to cook. Talking is talking. Ate food is eating. Waiting is waiting. Make sure that's without spaces after that. Yes. Resting, taking a nap. Let's recode that as resting. So it's going to be resting. And you can tell it to make all these changes, to merge and relabel and close, or you can, what I like to do is hit merge selected and recluster. That will recode all the data and then reapply the clustering algorithm. Sometimes you'll find new clusters in here that you missed. but in this case, everything looks pretty good. Talking, okay, that looks good for us. We don't need to do anything more with the data. We can close that window, and voila, there we are. This is our data, originally as entered, and then here on the right are all these nice, cleaner categories applied to recode that data. So the next step, of course, is to export our work, and we can just keep it in the same Excel universe here, and open up that file, and see that indeed, here we are, with our entries as originally arriving, and now in the cleaned up state that they're in with the help of Google or OpenRefine. So I hope this tutorial is useful to somebody else, and that you know, we can use these tools that are available to hopefully make the process of data cleaning and wrangling easier for all of us. Thank you very much. Have a nice day.